Now, our next sort of famous random variable is the binomial random variable. These are super important in application and for theoretical reasons. They, like the Bernoullis, they sort of help us build, they help serve as building blocks for other random variables sometimes. In fact, we'll see how you can actually construct binomial random variables out of Bernoulli random variables. Bernoulli, binomial, bricks, they all start with the letter B. Is that a coincidence? I think not. Okay? So bricks, like building blocks. Okay? So X is a binomial NP random variable, or sometimes we'll write X tilde, right? X is distributed binomial with these parameters, N and P, if it models the number of successes that occur in N independent Bernoulli P trials. Okay? So let's start with an example. Let's just start with an example. So, as usual, you didn't study for your quiz. You have 10 questions, and let's say there are 5 answer choices per question. Okay, 5 answer choices per question. So, so what's the probability that, you know, if you just blindly guess on question number 1, what's the chance that you get it correct? Yeah, it's 20%, right? There are 5 possible answer choices for question number 1. So, right, and you're going to do this 10 times. So you have 10 trials there, right? So think about it like this. Let's let X denote the number of questions you get right. And so maybe you want to know, what's the chance that X is 8? What's the chance that X is 8? Well, I don't know how to do that. What's the chance that you get 8 out of 10? Exactly 8 out of 10. I don't know how to do that, but I do know how to do this. You know, what's the chance that I get the first 8 correct and then miss the last 2? Well, these are independent events, right? And so I know that if I want the chance of the intersection of a bunch of independent events, which is what we have here, I want the chance that I get the first one correct and the second one correct and the third one correct, etc. And I can just multiply the probabilities of the individual events, right? It's the chance of getting one correct raised to the 8th times the chance that I miss raised to the 2th. All right. And the chance that I get one of those things correct is 20%, right? So 20% to the 8th times, what's the chance that I miss? Oh, by the rule for complements there, it's 0.8 raised to the 2th. Okay. Good. Now, what's the chance that what's the chance that I say get correct, miss correct? Let's see, that's 6, 7, 8, 9, 10. Okay, whatever. And guess what? It's going to be the same thing, isn't it? Because it doesn't matter what order you multiply numbers in. Okay, so again, that's 0.2 to the 8th times 0.8 to the 2th. Okay, and in fact, so it doesn't matter, you know, if I want the chance that I miss just the first and last one. 1, 2, 3, 4, 5, 6, 7, 8. Okay. It's going to be the same thing. It's the same thing. Okay. So now I think I'm ready to maybe answer my original question. Notice that the event that x equals 8 is equal to the union of the event that I just missed the last two. Whoops. The event that I just missed the last two. Union with the event that I missed the last one and the third to last one, union with the event that I missed the first two, etc., 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 right? So really, and all these events are all disjoint, right? It's not possible to miss the last two and at the same time miss the last one and the third to last one. No. See, there's a conflict there and there. Okay. So, but both of these events here satisfy the event that x equals 8. Okay. So these are actual outcomes. Okay. So what I want to do then is, by the way we do basic probabilities is I want to count up the number of outcomes that form this event. And notice that their probabilities are all the same, right? The probabilities of all these outcomes are all the same. So the number of distinct ways to get the event x equals 8 is, dun, dun, dun. Can you figure this out? You just have to count up the number of ways that you can choose 2 places out of the 10 to put the misses, right? So it's 10 places, choose 2, or 10 choose 8. Okay, same thing, right? 10 choose 8 is 10 choose 2. Okay, so the chance that I get exactly 8 correct isn't that just going to be equal to? It's going to be the sum of the probability that I get rid of that summation symbol there for now, and you say it's like that, plus the probability that I plus dot 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 plus probability that I miss, and then, all right, okay, so all these probabilities are the same. I just got to count them all up. I got 10 choose 8 ways to do that, and what was that probability? It's 0.2 to the 8th times 0.8 to the 2th. Okay. All right, so this sort of gives us a big fat hint as to how to actually write down the probability mass function for a binomial. So if x is distributed binomial, with parameters n and p, then the probability that x takes on the value of k is just going to be n choose k times p raised to the kth times 1 minus p to the n minus kth. And this is, of course, for any k in 0, 1, 2, all the way up to n. Okay? Okay, so this is the probability mass function. This is called the probability mass function, or the PMF, the probability mass function. It describes the distribution for this binomial random variable. Okay. Oh, and by the way, so what's the answer to our question there? 10 choose 8. 10 choose 8 is that? It's 45 times 0.2 to the 8th and then times 0.8 to the tooth. It's real small. 7.3728 times 10 to the negative fifth. The chance that you get exactly right, exactly 8 questions correct, if you're guessing blindly, is very, very, very small. Okay. By the way, you can also answer this question with your calculator. The chance that x equals exactly k with your calculator, you can get with this TI-84 or TI-83. You can get by doing binom PDF, n comma p comma k. Okay, so for our problem, that's going to be binom PDF 10 trials, success probability of 20%, and we want to know the chance that we get exactly 8 correct, right? So I can put that in my calculator. That function is here. If you go to the distribution menu, second, and then distr, come down to option number A. Now you see there are two that look very similar. We'll do this one first. Binom PDF. That stands for binomial probability density function. It really should say probability mass function. Okay, but whatever. Pick that, and I got 10 trials. My p is 20%, and I want to know the chance I get exactly 8. There, it's exactly the same. Fan-freaking-tastic. Now, what is it? 7.3728 times 10 to the negative fifth. What if I want to know the? I mean, that's not usually what we want to know, right? This is so that this is the chance that x equals 8 from our example. In general, what's the chance that x is, say, less than or equal to k? This you can also, do with your calculator. I mean, if you were going to do it by hand, it would be sort of difficult, right? Because you'd have to add up all of these, right? P to the I times 1 minus P to the n minus I, right? You'd have to add up the probability mass function over all these values from 0 to k, right? Or, so this could be really difficult, right? If k is a really large number, you'd have to compute a whole bunch of these terms and sum them up. So we usually use a calculator, or spreadsheet, or a software program or something to do the calculation for us. And so in the case of our calculator, just do binom CDF in P K. You can see the difference there is the C. This stands for binomial cumulative distribution function. Cumulative distribution function. You can see that there's a C there and there's a P there. They're different letters of the alphabet. Okay, so for example, for our quiz problem there, the probability that what we really want to know is not the chance that we get exactly a certain number right, but what's the chance that you pass? You're going to pass this little quiz if you get at least 60%, right? 60% of 10 is 6. You want to know what's the chance that x is at least 6? Well, by the rule for complements, first of all, I'm going to turn this around because I know my calculator will get the chance that x is less than or equal to something. But so by the rule for complements, this is the chance that x is less than or equal to 5. All right. Getting at most 5 is complementary to getting at least 6. Question's correct. So then I can do 1 minus binom CDF 10 trials, success probability of 20%, and 5 goes in there, right? Let me come down here and find that thing. There it is, binom CDF. Binom CDF got 10 trials in there. 0.2, 5. Press that enter button there. We get Oops. Yeah. 0.9. I forgot to subtract that from 1, right? I think 1 minus the answer there. It's pretty small. 0.006369 about. 0.006369. That's small. So what does that mean? It means that if you don't study and you guess blindly at a 10-question multiple choice quiz with 5 possible answer choices per question, your chance of passing is extremely small. It's less than 1%. So study.